Hey geometers, this is Miss Backfish, and I am here to talk to you about some angle pair relationships. And first off, I want to point out that usually before we talk about this, we've talked about some other angle pairs, such as complementary, angles that are supplementary, angles that are adjacent, linear pairs, and finally vertical angles. And what I want to point out to you about these is with all of these, complementary and supplementary sort of being the exception, but with most of these, you're looking at angles that the pairs of angles rather that are at a single intersection, meaning like vertical angles. You have a single point of intersection and you have some vertical angles like here and here. Linear pair. You have a single intersection and you have a vertical angle pair. A linear angle pair. Linear pair. Like 1 and 2. That's a linear pair. Adjacent angles. All of these basically share a vertex. Vertical angles have the same vertex. Linear pair has the same vertex. And adjacent angles have the same vertex. Complementary and supplementary don't even really have to be in the same picture. They just have to add up to 90 for complementary or add up to 180 for supplementary. But in most of these, we're really usually looking at just one intersection of two lines or a line and array or segments, one intersection. In contrast, the ones we're going to talk about today, we're talking about two intersections. And we're talking about an angle from one of them and an angle from the other one and how they relate to each other. So that's the big difference here. Okay, so today we're moving on to those angle pairs formed at two separate intersections. And we're going to look at that in 1 second. But let me just name them first because you've probably heard of them already. There's corresponding angles. There's alternate interior angles. There's alternate exterior angles. There's same side interior angles, and these have another name too. Sometimes they are called consecutive interior angles, or even just consecutive angles, but they're consecutive interior angles. And then finally, sometimes we talk about same side exterior angles. A lot of books don't even have those listed, but so we can kind of mention them as an aside. All right, so these are the 5 types of angles we're going to look at today. And they are all angle pairs that come up when you have lines crossed by a transversal. So let's look at what that means. Here I have 2 random lines. There's nothing special about these 2 lines. If I draw another line that crosses both of them, that line is called a transversal for the 2 lines that it crosses. It's a transversal for this line up here and this line up here. It's kind of like it's joining them together by crossing both of them. And when it does that, it forms 2 distinct intersections. It intersects with this one up here. It intersects with this one down here. So when we talk about those angle pairs I just mentioned, all 5 of them, one of them is going to be from up here and one of them is going to be from down here every single time. Now, looking at this, there are other angle pairs that are already there. I could talk about vertical angles right here. I could say this angle right here and this angle right here. That's a vertical angle pair. Or I could talk about these 2 next to each other and say that's a linear pair. They're supplementary. So those are still going on. But the special angles we're talking about today, one of them is at one intersection and one of them is at another intersection. And they are both joined. The 2 intersections have to be joined by the same transversal. Okay? That's a way that sometimes little sort of trick questions catch you. And I'll show you what I mean by that. Okay, so coming back to the names of these angle pairs, the best way to figure out what's what with these is not necessarily to just memorize them, but to actually understand their names. Because if you understand the names tell you where they are. All right? And I'm talking about understanding what is meant by the word alternate. What is meant by same side. What is meant by interior, and what is meant by exterior. All of those words are telling me something about what the 2 angles have in common in terms of their location. Okay, so let's go back to that picture of my lines that are crossed by a transversal, and let's talk about where is same side, where is alternate, where is interior, where is exterior. Well, interior means between the 2 lines being crossed by the transversal. So here's 1, 2 lines that are being crossed by the transversal, The interior just means between the two. So all of this is my interior. Okay, so I'm afraid my video is glitching a little bit. Just want to make sure it's not for you. All of this in between the two lines that are being crossed by the transversal, that's my interior. So anytime I talk about angles and say the word interior, it's either going to be one of these two or maybe one of these two, because they're the only ones that are on the interior, meaning between the two lines. Same goes for exterior. Exterior means not between the two lines. So the exterior would be like out here or down here, any place that is not between the two lines. So if I say some angles are exterior, then I would be talking about angles down here maybe, or up here. Next, if we talk about alternate or same side, we're talking about sides of this transversal. Okay, so alternate means one of them is on one side and one of them is on the alternate or opposite side. Okay, they're not on the same side. So for instance, if I said something about alternate and I was talking about this angle, the only ones I could be talking about would be these over here, because I have to be on the other side of this transversal line. If I said something about alternate and I was talking about this angle, the only ones I could possibly mean might be over here somewhere. So alternate means it's on the other side of the transversal, and same side means it's on the same side. Okay? Okay, so let's start identifying these specifically. Let's talk first about alternate interior angles. The word interior tells me that I'm only talking about angles that are between the two lines. So maybe some in here. Okay? So it has to be an angle here, 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 here. In between, in the interior. Remember, this is all interior in here. The other thing here is the word alternate. So not only are my angles going to be in the interior, but one of them is going to be on one side of the transversal and one of them is going to be the other. Remember, your transversal is the thing that always is the line that joins the two intersections. So this is the transversal. So for instance, alternate interior angles with the one I just put a heart on. Remember, we're always doing one from one intersection and an angle from the other intersection. So it would not be any other angles up here. Okay? Alternate means I have to go to the other side of the transversal. I'm down here, but it's still in the interior. So that would mean this one right here. They're both in the interior. They're on opposite sides of the transversal, alternate sides. And one's at this intersection and one's at this intersection. That's not my only pair of alternate interior angles. There are two. The other one would be this angle right here and this angle right here. One is on one side of the transversal, the other one is on the other side. One's at one intersection, the other's at the other intersection, and they're both on the interior. They're both between the two lines. These lines aren't parallel. The two lines that are crossed by the transversal. So those are my alternate interior angles. Okay, so next let's talk about alternate exterior angles. All right, they have to be in the exterior, which means outside of between there, not between the two lines. Remember, this is my transversal because it connects this intersection with this intersection. So this is exterior up here, these two angles up here. These are exterior down here. Now they have to be on alternate sides of the transversal. So if one is over here, the other one could be over here. If one is over here, the other one has to be over here. They wouldn't be right here though, because even though those are on alternate sides of the transversal and they're both in the exterior, they're also at the same intersection. One of them has to be at this intersection and one of them has to be at the other intersection. That's what all these angle pairs are, is pulling one from one intersection and one from the other. So let's say I have, let's stick with the hearts and the asterisks. Why not? If I want to know what angle is an alternate exterior angle with that one, that's in the exterior. It's on the left side of the transversal, so I go to the other side, have to come down here to the exterior, and it's this one right here. Another alternate exterior angle pair is this one right here with this one right here. They're on opposite sides of the transversal. One's on the left, one's on the right. They're both in the exterior, outside of this interior space. And they're at the two different intersections. Okay, next, looking at same side interior angles. So they both have to be on the same side of my transversal. And again, this is the transversal because it connects those two intersections. So they have to be on the same side. One of them has to be at this intersection. One of them has to be at this intersection. And they have to be in between my two lines. So in this space right here between the two lines. So let's use dollar signs. This one and this one are where the money's at. That's two same side interior angles. They're on the same side of the transversal. They're in the interior between the two lines that are crossed by the transversal. That's about it. Okay, so we have another pair of same side interior angles. Let's see, what symbol have I not used? Let's use how about a little triangle? This angle right here and this angle right here. Those are also same side interior angles. And we'll go ahead and on this drawing talk about same side exterior angles. Again, they have to be on the same side of this transversal. This is my transversal. So on the same side of the transversal, but they have to be in the exterior. So like here and here. Those would be same side exterior, or here and here. Those would be same side exterior. Okay? Okay, our last special angle pair is corresponding angles. And corresponding angles can be a little bit tricky to see. There are also, unlike all the rest of them, there aren't just two pairs here. There are 4 pairs of corresponding angles between this intersection and this intersection. And one thing that I think is a little trickier is the word doesn't really tell you where to look. Okay? One thing about corresponding, though, is what it does mean that if I say that two things correspond, it's kind of like I'm saying they go together. So corresponding angles, I'm talking about angles that go together. And what that usually means is basically the same position at one intersection as at the other intersection. For instance, like the upper right corner of this intersection. The upper right corner of this intersection. Those are corresponding angles. Okay, let's switch back to symbols. How about the upper left corner of this intersection? Then I go down here and it's the upper left corner of that intersection. The bottom right corner of this intersection corresponds to the bottom right corner of this intersection. They just sort of go together. They're in the same position at their different intersections. And finally, let's see, what do I want to use? An asterisk. An asterisk. This is like the bottom left corner of this intersection. And so I go down here and it's like the bottom left corner is right here. So they're basically two different intersections, two different angles at these two different intersections that are sort of in the same position at their particular intersection in terms of where they're located with respect to everything else going on at the intersection. Okay, so one thing that we did here was we looked at two lines that both sort of looked kind of horizontal, and they were crossed by a transversal that was kind of vertical. It doesn't always have to be that way. Looking at this particular situation where we have two intersections, here the transversal is right here. And if I ever have trouble locating the transversal, it's always the line that goes between your two intersections. It's the line that connects the two intersections. So here's my transversal. So if I'm talking about interior for this picture, that would mean in between the two lines crossed by the transversal. So the interior would be like here. And the exterior would be out here. And for this picture, same side of the transversal would mean sort of either everything above it is on the same side, everything below it is on the same side. So it doesn't always have to look exactly like the first one. The other thing I want you to notice is all of these angle names, all these angle pair names that I've been using, never once have I said a word about these lines being parallel. So I know some of you are wondering about that because you've seen this before and you're like, Aren't those lines supposed to be parallel? No, they're not supposed to be. And all of these names are names of angle pairs that happen when any two lines are crossed by a transversal, whether or not the two lines are parallel, okay? So there are alternate interior angles here, there are alternate exterior angles here, and so on. Let's go ahead and identify those. Okay, so this would be a good time for you to go ahead and pause your video and see if you can complete these. All of these, there's going to be two pairs of numbers, numbered angles here, that fall under each of these categories. So go ahead and hit pause and see if you can figure them out. Okay, so alternate interior for this picture, that would be 3 and 7. Angle 3 and angle 7 are alternate interior angles. Another pair would be 2 and 6. Alternate exterior, 8 and 5. Another pair of alternate exterior angles would be angle 1 and angle 4. Same side interior, 2 and 3 are same side interior. They're kind of like they're in a row. They're really close to each other. Another pair of same side interior is 7 and 6. Same side exterior, we've got 1 and 5. And 8 and 4 right here. Now, that's everything except corresponding angles. Now, remember, for corresponding, we have 4 pairs. So go ahead and hit pause again and see if you can list all 4 pairs of corresponding angles for this picture. All right, we've got 1 goes with 6. 7 goes with 5. 8 corresponds to 3, and 2 corresponds to 4. Okay? So once you have practiced this a little bit, you're ready to talk about what if these two lines that I said they don't have to be parallel or anything special to make all of these things true. What if they were parallel? That adds just a little bit further layer, one more layer to the story. If these two lines that are crossed by the transversal are parallel, then special things happen for all of these angle pairs. And the quick, short list version of what happens is all of those special angle pairs will either be congruent or supplementary. So let's look at that. So here I have two lines crossed by a transversal. This is the transversal, the line that goes between those two intersections and connects them. And what I want to point out to you is that sometimes you might be told that they're parallel, the lines, and sometimes you might be shown. If I have little matching arrows on the line, not at the end, but on the line, that's a way of showing you they're parallel. I could have one set of matching arrows. I could have two set of matching arrows. They could look kind of like triangles. But if I have matching arrow symbols in the mid, like not necessarily the middle, but on the line somewhere, not at the ends, that's a way of showing you these lines are parallel. So that's what I've just told you in this picture, is that those lines are parallel. So first, let's look at our facts about what happens when lines that are parallel are crossed by a transversal. If parallel lines are crossed by a transversal, then alternate interior angles are congruent. This is just a symbol for like angles. Sometimes you have this drawn across it. So that's just sort of shorthand to say angles. And this is the symbol for congruent. So this is saying alternate interior angles are congruent if I know that my parallel lines have been crossed by a transversal. Actually, let me restate that. If I know that the lines crossed by the transversal are parallel. Okay, so here I do know that they're parallel because I drew it that way and I marked it that way. So my alternate interior angles are going to be congruent. So what that means here is that this angle and this angle would be congruent. And this angle would be congruent. Remember, congruent means the same measure. So for instance, what if this was 110 degrees? That would be as well. Now remember, these are a linear pair. So if that's 110, this is 180 minus 110. So this would be 70. And this is an alternate interior angle with this one, so that one would be 70, which also fits because these two add up to 180. Okay, the next little factoid here is that if my lines that are crossed by the transversal are parallel, then alternate exterior angles are also going to be congruent. So first, let's identify our alternate exteriors. That would be like this angle up here and this one down here, or this one right here with this one over here. Well, it kind of makes sense that they're congruent just because we also have vertical angles here. So for instance, if that's 110, this has to be 110. And if this one's 110, this has to be 110. So I see it. I see that my alternate exterior angles are congruent. Okay, and I can go ahead and use that same symbol. I didn't leave much room for it. And then the same thing happens for these two that are also alternate exterior angles, because they'll both be 70 according to what we know about vertical angles. So we could prove this using vertical angles and linear pairs. Okay, the next one I was going to talk about, but I changed my mind, was same side interior angles, which we also call consecutive interior angles. I changed my mind because these are the one that are sort of like the odd man out. They're a little different. Okay, so let's go ahead and skip instead to corresponding angles. Just like alternate interior, alternate exterior, if my lines that are crossed by the transversal are parallel, then the corresponding angles are congruent. Okay, and we can see that based on the ones we've already marked. Let's look at our corresponding angles here. This angle right here, this 70, corresponds to this one right here. They're both sort of the lower right-hand corner of their intersection. Okay, let's do another one. How about the 110 up here? All right, that's sort of like the upper right-hand corner of this intersection. So let's look at the upper right-hand corner of this one. It's the same, it's 110. And the same thing could be said about these two. Here's my two corresponding angles. The 70s correspond and they are congruent. And finally, the 110s here correspond and they are congruent as well. So let's go back and look at what about consecutive interior or same side interior. They're the ones that are a little bit tricky. They're a little bit different, and so they can be harder to remember. Consecutive interior angles are like this one right here. And let's come over here. This one right here. They're on the same side of the transversal. Their consecutive is like in a row. Okay, and they're in the interior. Those are not the same. 70 and 110 are not the same. But they do have a relationship. They add up to 180. So that is what is always true of same side interior angles. They add up to 180. And the word we have for that is they are supplementary. Okay, these are actually theorems and postulates. Like there's a theorem that says if parallel lines are crossed by transversal, then alternate interior angles are congruent. There's a theorem that says if parallel lines are crossed by transversal, then consecutive interior angles are supplementary. The big difference, don't get hung up on the difference between the word postulate and theorem. Technically, theorems can be proven and should be proven. Postulates we sort of just accept. So the one we sort of accept here is the postulate is corresponding angles generally. But a lot of times you don't have to really get into the nitty-gritty of that. You just have to know that these things are all true. Okay? Now, one of the main things I want you to notice here is how many different angle measures I have in this picture. If everything is either congruent or supplementary, then that means I only have 2 angle measures in the entire picture, assuming my lines are parallel. Everything in this picture is either 110 or 70, and that's always going to be the case when your transversal crosses 2 parallel lines. So let's look at another one like that. Okay, so this time I drew my parallel markings a little differently, so you can see sometimes they're triangles. And then here's an intersection, here's an intersection. So this is the transversal, right? Let's go ahead and just write that. Okay, so all I have to know to be able to figure out all these angle measures is one of them, because everything else is either the same as that one or supplementary to it. So let's suppose that I knew that this angle right here was 113 degrees. Well, I could use vertical angles to say that so is this one. That's one way I could say that. I could use alternate exterior angles to say that so is this one. These are alternate exterior angles. I could use alternate interior angles here and here to say that so is this one. So all of those angles are going to be 113, which means all the other angles have to be 180 minus 113. 180 minus 113 is 67. So this angle is 67 degrees. This angle is 67 degrees. These two are vertical angles. This one is an alternate interior angle with this one over here. Alternate interior angles will be congruent. And there's a vertical angle. Okay? Okay, so what if I have a problem like this? What if I have, and I know that these are parallel, and someone tells me that this is 2x plus 6 degrees, and this one is 4x minus 14 degrees. All right, the first thing you always have to do if you need to solve, we're usually solving for x. To solve, you have to have an equation. An equation is a relationship. So the first thing you have to do is figure out what is the relationship between these two things so that I can use that relationship to write an equation. Well, the first thing I notice is that those are alternate interior angles. Here's the transversal. They're on opposite sides of it. They're in between the two parallel lines. Those are alternate interior angles. And remember that when my lines are parallel, alternate interior angles are congruent. So I know that this has to be congruent to this. That tells me that these angle measures have to be equal. So that's what I'm going to write as an equation. I'm going to say 2x plus 6 equals 4x minus 14. And then I can solve that and find the value of x. So let's do that real quick. And it turns out that x is going to be 10. So what angle measure? Sometimes that's asked. Sometimes you're asked to find x, and sometimes you're asked to find the angle measure. So let's go back and say, well, if they ask me for the angle measure, I'd have to put a 10 in there. And it turns out that they're both 26 degrees. And by the way, by plugging back in like that, you kind of are checking yourself. Because we already know these two angles are supposed to have the same measure, and I got the same thing both times. So we're good. Okay, so what about this pair? First of all, let's go ahead and assume that we know that they're parallel, these lines. And then let's see if we can figure out both x and the measure of each of those angles. Remember, the first thing is you figure out what is the relationship between these two. What kind of angle pair is that? Then we use that relationship to write an equation. Go ahead and pause your video and do that. And then you can watch and make sure you got it right after you're done. Okay, so the relationship here is these are same side interior angles. Same side interior angles are supplementary, not congruent. So I'm not going to say this equals this. I'm going to say that together they add up to 180. And then I can solve that equation. I get 5x plus 80 equals 180. Subtract 80 from both sides, and I get 5x equals 100. And x equals 20. So there's the value of x, and if I want to know the angle measures, I can go take that back and plug it in. When I do, if you haven't, pause and check. What I'll get here is 132 degrees and 48 degrees. Check yourself by asking yourself, are these two supplementary? Do they add up to 180? Because that's what same side interior angles are supposed to do. And yes, they do, so we did it right. All right, I hope this has helped you. I came in under 30 minutes. Sorry it's so long, but we covered a lot of ground. So hopefully this has helped you, and I'll see you next time.